Okay, hi everyone. Welcome to Sama's webinar on how to optimize data quality for better ML model performance. I'm Saul Miller, Sama's Vice President of Product Management, and I'll be your moderator for today's panel discussion. First, let's start by acknowledging a simple reality. Without ground truth data, there's no ML. And yet, a recent survey of professionals working on ML projects showed that 78% of their projects stall at some stage before deployment. And 81% admitted that the process of training AI with data is more difficult than they had expected. That survey showed what many of us probably already knew, that the path to developing high-performing ML model that's actually going to deliver business value in production, it's a complex problem, often no clear proven path to success and lots of risks along the way. In Sama's 15 years of annotation experience, working on some of the most ambitious and innovative ML projects, we found that one big risk is reliably scaling data annotation volumes and quality. This risk is often fueled by human error, unclear assumptions, ambiguity of images, the subjective nature of the annotation task. Do any of these sound familiar? As we go throughout this session, I invite you to reflect on what risks are affecting your models and how they can be mitigated. We see these risks across industries, across use cases. And even with the awareness of the risks, it's not so simple to get it right in practice. So in today's presentation, we'll be sharing insights that we've learned along the way in Sama's 15+ years of annotation experience, supplemented by some internal proprietary research and data annotation operations best practices. And I'm committed that by the end of the session, you will leave with a much better understanding of data annotation quality risks and how to mitigate them, as well as some practical recommendations for next steps. The good news is I won't be doing it alone. We'll be joined today by some of my esteemed colleagues to share their viewpoints from various functions within Sama. So let's meet our panelists for today. Pat, you could please introduce yourself.
Hey folks, excited to be here today with you. I'm Pat. I am a product manager at Sama focused on data quality. And what that means for our product is I'm working on the tools and processes and features to enable our internal teams to deliver high quality work to customers, as well as providing those customers with the tools they need to have high confidence in the data that we deliver to them. Prior to Sama, I've been here for almost 2 years. My background's in machine learning engineering, so I spent a few years in computer vision, working on software and technology around image registration and entity extraction for automatic document processing.
Hey everyone, my name's Eric. I'm an applied scientist in machine learning at Sama. I've been here for about a year and I work on projects related to annotation quality, as we will be discussing, all the way through curation, data curation. My background is in deep learning and computer vision, where I got a master's at McGill, and my research focus was on self-supervised learning.
Hello everyone. My name is Aldrin Membo. I'm the Senior Director for Quality and Training, managing quality for the East Africa team, as well as training for all our associates coming into projects and to ensure that we are delivering high quality tasks to our clients and to fulfill the expectations.
Perfect. Thanks, everyone. And just some housekeeping, we'll make sure to save time for questions after each of the panelists have had an opportunity to speak. So please feel free to submit your questions through the Q&A panel, and as they come in, we'll curate them, see if they should be answered in real time, or we'll definitely save some time at the end to address them. So thanks for being here. Why don't we jump in? So Pat, as a product manager who's focused on data annotation quality, engaging with our customers on their quality needs and building products optimized to deliver on those needs, what are you seeing as the most common challenges?
For sure. So you gave a great overview about some trends in the industry and people starting to focus and invest more in data quality. The term data-centric AI is getting thrown a lot. And I want to double click on that and start by pretty much explaining the process for most companies to get to that journey of getting to high data set quality, and start by focusing on the challenges, right? So two main types of sources of error that we want to focus on. The first being the underlying data itself. right? The data that you've collected and that you now want to get annotated. So what we see often is that a bunch of different issues can come up along the way. Oftentimes, there can be times where the sensors themselves are noisy, right? Whether it's because of poor calibration of the sensors, the fact that they're obstructed, that they're damaged. And obviously with poor sensors, it's very hard to get high quality annotations to train your model. Again, another underlying data issue, sometimes the data itself is very ambiguous. One of the cliches that we see often in the field is a mirror in an image or a reflection of an object in a window, right? These are things that can often be very confusing. And similar story here with our copper colored friend on the right. Sometimes the underlying data itself is very ambiguous. Another big source of noise, and when we refer to noise, it's sort of errors that creep into your data along the way, is annotation instructions themselves. So oftentimes, it's hard to be very clear in the annotation instructions. So a parking meter, for example, kind of a dual parking meter, should that be annotated as one or as two parking meters? And then edge cases are a frequent problem as well. No matter how many you try to document, right? We see instruction manuals that are hundreds of pages long. Edge cases pop up. It's just the nature of the world. It's hard to cover every possible scenario that you think that you can see in annotation instructions. Another issue you might come up with is the fact that instructions can be subjective, right? You can be very clear. You can try to cover as many edge cases, but in the end, sometimes the nature of the annotation is subjective and left up to the annotation team. For example, you could have instructed the team to annotate any person that is less than 50% occluded, right? So most of their body is visible. Well, that's not necessarily very easy to measure, and sometimes it's left up to the annotator to make a call, right? In this photo, I'm not so sure which ones I would annotate versus not, even with very clear guidance. And then in the picture at the bottom here, if you're asked to basically flag whether an accident is going to happen, that's just a very subjective task by nature. And then the last thing, which is also very important, is that instructions are dynamic, right? When you create your instructions at the beginning of a project, as you're setting off on your ML development lifecycle, you've probably only seen a very small slice of your data. And the instructions that you create are probably good for that slice, but as you discover more and more of your data, and as the annotation team also goes through it, there are things that pop up. You might need to change your instructions. And so this dynamic nature of instructions makes it, a bit harder to get to that top-notch data set quality. So I hope you can understand why things are challenging, but it's still very important to focus on this, right? What we see often is companies underinvesting in data quality. And what that ends up meaning for most companies is a higher total cost of ownership. So your project, your product development ends up costing you a lot more than what you set out, just because you've underinvested in that data quality. And similar thing with a longer time to market, you might have to push out your release just because of data issues. And what we're talking about when we talk about data issues in this context is probably you're going to have the need to frequently rework annotations, right? So if you find issues in the data, sending them back to the annotation team, reviewing them again, and this endless cycle can go on and on for quite a while. And similarly with the calibration cycles, you might be just out of sync with your annotation team, right? If you haven't focused on and invested in clear annotation instructions, there might be a disconnect with the annotation team, and getting aligned might take you much longer than you might expect. And then finally, you might need to spend a lot more QA effort and resources. If you're working with a partner who you don't have the utmost trust in, then over the entire life of the project, you might need to spend a lot of effort QAing, versus if you invest a lot upfront, choose the right partner, then you might be able to, based on that confidence in the relationship, reduce your QA costs over time. And as I just mentioned, one of the most important things that you can do, knowing that it's very challenging, knowing that it's also very important, is to pick the right partner. So a team which is laser focused on calibrating with their customers, that has deep expertise in creating quality strategies, executing on them with robust processes, that is fully dedicated to your project, and perhaps most importantly, that's proactively raising edge cases, right? Because the team that you choose is going to be the team that's going to see all of your data in its entirety. They're the ones that need to be proactive, raise issues as they come up, and be really a valuable partner for you on your machine learning journey. What you shouldn't do is just go for the cheapest crowdsourced option. If you do, what happens most of the time is that a lot of your resources are going to be spent on monitoring bad actors, which is not the case with a provider that has an integrated workforce, for example. And you're going to be struggling trying to navigate a relationship with a team that might be out of sync, decentralized, and just not able to handle your complex workflow. Some concrete examples of these that we've seen. So what happens often is that, as I mentioned, some companies at the offset will choose the cheapest automated option. But oftentimes we get companies that come back to us after a couple of years because they spent a lot of time working with this cheaper partner and realizing that the data that's outputted is just completely unusable for their model. Another situation we see a lot is that some of our customers rightly want to diversify their partnerships. And so they work with multiple annotation providers. But in one case, we had a retail startup which had to significantly delay their launch because of one problematic relationship with an annotation partner that was causing delays because of rework and a lot of false starts, kicking off new workflows. And this is just obviously not a situation that you want to get into.
Thanks so much, Pat. It's definitely really fascinating to see how some of those risks that I talked about at the beginning start to manifest in real ways for our clients. And later in the webinar, we'll hear from Aldrin on a little bit more about what some of those best practices can look like in more detail when it comes to managing those annotation partners. But for now, let's shift gears a little bit to maybe a more academic viewpoint. We have Eric Zimmerman here, an applied scientist on our in-house ML team, who, amongst other things, do cutting-edge proprietary research in our industry. It's research that's enhanced by being embedded within an annotation organization and having broad visibility to a variety of real-life customer use cases. And so, Eric, definitely trade-offs between annotation precision levels, model performance. It's a tricky subject with real impact for our clients. So please tell us, what does our research say?
So we're going to start off a little high level, and we're going to kind of try and paint a picture of what's going on from the perspective of a machine learning task. And then we're going to look at a little bit of something like detection metrics. These are IOUs, especially in regards to what the properties of these metrics are. From there, we're going to kind of try and frame things in terms of annotation quality and how annotation quality can affect model performance based on how we look at these metrics and we use them. We're going to show that we have an empirical study to kind of support some of the claims we're making. And really the punchline here is that you can pick particular pixel tolerances that are better specified to the type of task and goal of your application, all while saving the most amount of money and time suited depending on what you're trying to do. So at a high level, we got to think about what are tasks and we should define them. So in a prototypical ML system, you're going to be focusing on the model, but really the model is formed from data and labels. This model is usually trained to accomplish some kind of task, whether it's classification or regression, or some kind of subset of these operations, kind of like detection and segmentation. But ultimately, you're fitting this into some kind of application, and the application either serves some kind of end user and really has some kind of business value. And the problem we often see is people are very focused on the task, but very granular metrics within the task. And there might not be a particular benefit in just optimizing a very, very particular metric if you're accomplishing what your application is set out to do. So label tolerances should be specified based on your downstream application requirements. And what you can do is you can reduce your tolerances to the level of your application to save as much time and money as possible. So there are a lot of different kind of tasks, but we're going to focus on detection and segmentation. And really at a high level, you can break this down into two different kinds of understandings that are required for an application to make a decision. You have something like fine grain understanding, and here you need pixel level precision. This could be photo editing or medical intervention, where you have to understand the volume, area, boundary of and the topology of your pathology. And here you need to be very, very strict with what you're doing. However, something that requires coarse grain understanding, such as object level precision, you might not need to be as focused. So in this case, localizing, if you're tracking something or if you're counting, these are much higher level, or it requires a lot higher level understanding. So better understanding your system requirements should lead you to better specify what kind of tolerances you need on your annotations. So again, we're going to be focusing on detection and segmentation. And really what we're going to be looking at is intersection over union, which is a very popular metric in this space. This metric is a measure of similarity between masks, whether it being a segmentation mask or a box mask. And really it is the criteria used to determine what's considered a detection. And there's some pros and cons, but the idea is you're going to be comparing the overlap between your mask, whether it's two predictions or a prediction and a ground truth, and you're going to normalize it by the union of these two boxes. So IOU is great, but it's really important to understand what is this metric sensitive to? And if we can understand the sensitivities, we can better specify what's going on. So the absolute size of the mask is really what's being compared. So this is a measure that's measuring absolute pixels to absolute pixels. One problem though is because of this normalization, you will be sensitive to size. What we see is that smaller masks are more sensitive to changes, especially in the boundaries, than larger masks. And we can take a look. We have a little graphic on the right. What's being done is we have some kind of polygon, and what we will do is we will stretch it or we will contract it, and we can look at the difference in IOU as a function of the deformation done in this polygon. And as you can see in blue, the very, very, very small instances see an enormous drop off in this metric very quickly. And so you kind of have to play around with, well, how do I calibrate my system to be able to make detections in this regime? Is it even possible to guarantee confidences in this regime? And so we can kind of specify how well a system is doing by understanding, how much wiggle room do we have using this metric. One thing that's really important to note is IOU doesn't really characterize the similarity between the contour. It's really just overlap and may not be the best for shape. So one of the big things here is uncertainties. So even if we want really, really tight boxes or tight masks, we're always going to be limited. And Pat touched on this a little earlier on, but one of the big things is sensor uncertainty. So if you have pixelated transitions between boundaries, you're never going to be able to perfectly get this really, really tight contour, and you might not need to. Another thing is if you're using something like a polygon, you'll be subject to the rasterization errors, and so you'll always have some kind of boundary uncertainty. If you take a look at the two GIFs that are kind of going off on the side, you can see this is the visual interpretation of different masks that are dilated by 1, 3, 5, 10 pixels. And as you can see, the car, which is a lot smaller, well, those 1 pixel or 3 pixel changes represent huge, huge, huge deformations on what you're annotating. While the zebra, you can see even a few pixels, no real difference. You will sufficiently be able to detect and find whatever object by comparing these. So it's not always necessary to have these really, really tight tolerances. It might not even be possible. So in order to investigate this, not only in terms of like an IOU perspective, we really wanted to see the effect of label noise on model performance. And so the way we did this is we used SamaCoco, a data set that has been released, and we trained a model using detection and segmentation masks, treating SamaCoco as the gold standard because it was annotated with very tight guidelines on boundaries. So we wanted to make sure the boundaries were as tight as possible. What we then did is we used a variety of methods to simulate realistic changes to the polygons. And we did this only on a training set. And then what we did is we evaluated the model on a clean validation set where no changes were done to see how well the model was able to learn even in the presence of this noise. Because this is a COCO data set, we used mean average precision, which is based off of IOU, and we saw certain trends. So really the summary of what the results that we saw is that systemic noise leads to systemic bias and degrades quality performance, while models were able to be robust to realistic random noise. And so when we say systemic bias, this would be stretching a boundary by something that's very constant. However, this is not something realistic. Like you would never see an annotator constantly give you a 3-pixel boundary or a 5-pixel boundary. It'll be a mix of being very tight in some regions, and in regions that are a little uncertain, you'll have something that's a little more, there will be higher variations. And that's really what we're going with this random noise. So the punchline to this is boundaries that have mixed biases outperform those significantly with constant biases. As expected, larger instances were way more tolerant to the changes in boundaries at training time, and smaller instances were very, very sensitive to these changes. So using these results, we can see that it's actually possible to be a little looser on our tolerances, depending on what we expect to see in the wild and how we expect to calibrate our system. So quantitatively, this is just a very high level of the average precision, so mean average precision used in COCO. And so we have our baseline in green. The dependent was doing size-dependent label injection, like noise injection. So this would be more realistic of what you would see with an annotator. We had random noise, which is not size-dependent, and then you had something that was constant. And what you can see visually is there isn't much change for the large instances, but as the instances get smaller and smaller, you see the importance of picking your tolerances become a lot higher. But in these higher ranges, you have a lot more leeway.
Thanks so much, Eric. Definitely the results of that research can lead to some really significant impacts on an ML project. Definitely kind of overestimating the precision level you might need it for your use case. You may be consuming too much budget too quickly, or underestimate like some of the risks that Pat was highlighting, and you may struggle with data quality and precision levels and not see the lift in model performance that you're looking for. But now I'm really excited to hear from Aldrin, our Senior Director of Quality and Training with our delivery operations in Nairobi, and really share more about best practices for annotation teams. What does it take to really deliver annotation quality at scale there in a production environment?
All right. Okay. Thanks for the preamble, Saul. Hi, everyone. So we'll start off by stating that quality is inherently subjective. There exists nuances based on different outcomes ML professionals are after, even if their projects are of a similar nature. So that's why a shared understanding of these outcomes is very important and necessary to help develop customized QA processes to achieve a win-win situation. Right. So the initial step in customizing this QA process is by gathering client instructions ahead of kickstarting the project. So here we want to analyze these instructions, identify any potential errors, and develop precise task instruction guidelines. Thereafter, we spend time analyzing sample tasks, what we refer here to as seed, and then identify whether there exist any edge cases which have not been captured in the instruction guide. These are then added to a shared question log where we closely collaborate with our clients and provide inputs based on our research experience and expertise in this area. Finally, we develop a completion strategy for delivering all tasks within agreed timelines, where we can apply strategies such as task routing, which refers to maybe sending specific tasks to a specialized group of team members to facilitate a quick TAT on task processing. To articulate how we add value, we also provide suggestions on approaching tasks and evaluating whether this has any impact on the outcomes. For example, in the illustration for a self-driving vehicle annotation project, typically the instructions would have us annotate all the projects within a certain radius from the vehicle with cameras and sensors. But here we ask, is it really necessary to annotate all objects, even those on the other side of a 9-drivable area or a road divider? Will this really affect the model? We can definitely help save a ton of time and project budget if we focus on the areas that really, really matter for the client. So next we develop what we call a quality rubric, which in simple terms lays out the criteria for task acceptance and defines the scoring from excellent to poor on a graduated scale. Here again, we employ research-based guidelines for these criteria to offset any ambiguities and ensure we have an optimal blend of annotation efficiency and quality. In no particular order, the rubric helps to 1, identify errors and penalize each error. 2, score tasks to help correct errors before delivery. 3, help keep the teams calibrated. And lastly, eliminate any sources of quality issues. Now, some examples of errors that might be encountered by our teams during task processing are incorrect labeling, missed objects and points during annotation, reflections of bloom, where object reflections are annotated mistakenly, as Pat alluded to earlier, tracking of objects across video sequences, and precision of the size of the bounding boxes in annotation projects. Some examples of errors that might be, So thirdly, we review the edge cases where we define these edge cases, which cannot be easily classified into any category. We then develop guidelines on how to handle these edge cases and then train our team members on how to handle them and document them in a centralized system. Then we establish a regular review process to handle these edge cases that annotators cannot handle on their own, and then monitor and update these guidelines with changes that creep up as expected in ML projects. Now, one thing to note is that in some cases, consensus amongst our team members helps to generate solutions to a majority of these edge cases, which showcases our experience in adding value to the prescribed task instructions. So as illustrated on the screen, where task instructions at times may not specify how to annotate articulated vehicles or cars pulling a wagon or a trailer. So the question is, do we annotate these by grouping all these, or do we want to annotate these separately? So these are some of the things that really come up when you're trying to calibrate with the client to ensure that you have a common understanding. So turning the gears up a bit, we then dive into training our project teams. So here we follow a proven methodology to ensure that we deliver projects on time and exceed expectations. So we start this off with vetting the team members who will work on the project to ensure skills and competencies are properly matched. We then embark on delivering the specialized training while employing some principles we found to be critical to the success of the project, such as continuous feedback, tight collaboration, breaking down the training into manageable chunks while continuously keeping the team engaged and reiterating the why. So this is basically showcasing to the team what's important to the client and ensure that everybody understands what is very, very critical for the project success. So periodically, we conduct pulse checks on the team to gauge understanding by continuous assessments, which can take the form of theoretical tests before diving into practical or hands-on training, where lots of time is spent on interacting with sample tasks to reinforce these task instructions. This is concluded by a final evaluation or assessment, or in other words, certification, to graduate the best team members into production. Now, training does not stop here. We conduct continuous evaluations and step in to support project teams by reviewing performance data or error analysis data on a daily basis. And this is to drive continuous improvement and reduce errors. This is how we are able to develop deep expertise in the multiple projects by ensuring our teams really understand what's critical for our projects. Now, bringing all this together, quality assurance is not an event. It starts right from the onset of the project and continues alongside the life cycle of the project. So right from the development of the quality rubric through to delivery, we ensure that our teams are thoroughly trained. We then pace production by graduating expectations in the first few days to nail it before we scale it. It is equally important to provide a tight, continuous feedback loop and hold our team members accountable for their submissions and offer coaching wherever that is needed. Our industry expertise shines through by improved efficiencies and high quality deliverables, thus ensuring ML outcomes are adequately catered to. So earlier we talked about having a shared understanding with our clients. So this is also not a one-time event, but a continuous process where we collaborate closely to calibrate and level set on expectations. So we know that data sets are ever changing, and this collaboration is critical to ensure that we are all on the same page and the project is ultimately successful. A couple of activities during this collaboration are things like reviewing the question log or edge cases and providing feedback and next steps. Then retraining teams on these updated instructions coming from these edge cases and ensuring our platform is reconfigured whenever we have changes, and checking that the delivery or integration via API is also updated anytime we have like minor shifts in how we are delivering these tasks. And that's it. Thanks, everyone. Back to you, Saul.
Thanks so much, Aldrin, for sharing a bit of your expertise and SAMA's best practice, and also your passion for delivering quality at scale. It comes through so clearly, and also to highlight how important the tight integration is between an annotation team and the end stakeholders. So now we do have some time for questions, either for me or for any of our panelists, and then we'll wrap up with some key takeaways and next steps. Just giving me 1 second to look for questions that are coming through. Okay, so the first question is coming through. It says, can you tell us more about why your customers had to rework the data annotated by other vendors? That's a great question. Maybe, Pat, you might be the best suited to take a stab at that one, and then Eric or Aldrin, feel free to jump in.
Sure thing, yeah. Yeah, I mean, as I mentioned, we saw that there are a lot of reasons why reaching a high quality data set is quite challenging, right? And I think a lot of our customers, when they set out on this journey, they view annotation as more of a, just not in the right light, and they're looking for a relationship which is more of a provider as opposed to a partner and collaborator. And so when they partner with somebody who's just going to provide annotations in sort of a black box and not ask any questions and not be proactive, over the long run, they find that the results that they're getting are not up to par and are not able to basically provide value for their use case. So the reason they come back to us is they realize that it is important to choose the right partner and establish that collaborative relationship in order to really tackle this important and difficult challenge of reaching high data quality.
Makes sense. Thanks, Pat. The next question says, how exactly do you automate some of your QA processes? So we spoke a lot about kind of the tight integration between annotators, quality reviewers, customers, but certainly automation has a role to play here as well. Maybe Aldrin, could you speak a little bit to some of the automated techniques that we're able to embed into the annotation workflow and the types of errors that they might catch?
Right. So QA processing or QA reviews of tasks on a manual way at scale is really not sustainable with the project budget and everything else. So we employ things like auto QA. So auto QA basically looks at logical errors that may occur in the data sets. And one example is the instructions may look like you can only annotate maybe 2x3 pixels within a particular object. But then we have annotations which are larger than that. So auto QA will actually come in and capture this and reject those tasks back to the annotators. And then we taper down our review percentages just based on previous scores. So how we do this is we look at performance data of all our annotators, and we taper down the review for those annotators whose tasks are really meeting the mark, or they don't need any additional review. Maybe they're meeting everything that has been specified in the quality rubric, and the task are actually passing the scores to be delivered to the client. So those are some of the things that we do to just ensure that we are moving more towards automating the QA review as opposed to doing everything manually.
Great, thanks. I think we have time for just 2 more questions. So this next one, likely Eric, I think is going to be a good fit for you. It's talking about, it says, in the examples with the precision tolerance experiment, the contours in the GIFs were expanding. How would you expect if actually the contours were cutting into the object or actually too small, and any impact that would have on model performance?
So the reason we focused more on dilation is because we see annotators always try and overestimate. I think that's what we see quite a bit in terms of guidelines. We had run experiments where boundaries were eroded to a similar extent, not as thoroughly, and we saw the same kind of behavior. In some cases, we saw that when there was a mix of erosion and dilation, you performed almost on par with the baseline, showing that if your model learns to estimate the mean or the average contour kind of shared across training, you can still do very, very well. So I think whatever was presented in terms of the stretching, you can apply it directly to the contraction.
Great, thank you. All right, maybe one last one. Pat, probably over to you. It says, how do you define edge cases when you set up instructions and rubrics?
Yeah, great question. So these are things that are inherently hard to define, right? It's by definition things that are not covered by your annotation instructions. And as I mentioned earlier, these annotations instructions are these living, breathing things that are evolving over time. And basically anything that we see that we don't know how to annotate and we need to align with the customer to basically decide on how to handle certain cases, that's what we define by an edge case. And then there's that category of edge cases, which are just not covered by the instructions. There might also be others which are covered by the instructions and we know how to handle properly and we're confident in what we're doing, but we think that we might want to raise them to you because it's just a very rare or bizarre occurrence. And you might want to specifically look at it and kind of understand, basically get some more understanding around what's in your data to get a better, comprehensive understanding of your data sets. So those are kind of the 2 main, I guess, types of edge cases that we consider.
Perfect. All right. Great. Thank you, everyone. That'll be the last question that we do. So let's start trying to tie this all together and talk about next steps. We've heard about some practical examples and challenges in data annotation quality. We've heard about some empirical research and also some of the best practices in our production operation. So what's next and what can you take away from here? So the first key recommendation is definitely to read Sama's data quality ebook. I'll just flash a slide with a little bit more detail, and I think you should, you can see now from Rebecca, I think Rebecca, the link in the chat. It's an ebook that we published a few months ago on building quality models for autonomous driving. It touches on a lot of the themes that we've spoken about today, but goes even deeper. So it's a great deliverable to spend some time in as a next step. Also, talk to your teams. Depending on where you are in your ML development lifecycle, where you are in your annotation maturity, these challenges and pain points we've spoken about are pretty pervasive. So How are they determining some of the right data to annotate? Do they understand where their model runs may be falling? Look into some of these risks and root causes that we've spoken about today as possible causes and how to mitigate them. Which leads to the next one, is really be proactive about managing data labeling and risk. We spoke a lot today about how challenging this is, about how a lot of folks are failing at various points along the way, and be proactive here, be clear, start with your end goals in mind. It's a lot of, I think, what I take away from what Eric's sharing there with the different use cases, depending on what you're actually trying to achieve and how that's going to inform some of those trade-offs between precision and model performance. And definitely make sure you're finding the right labeling partner who can grow and scale with you and takes that comprehensive approach to quality management. And definitely keep in touch. This is just the beginning of a conversation. We're living and breathing this every single day. And you're welcome to book a virtual coffee with us to discuss how Sama may be able to help. I'll kind of just flash this last slide here with our LinkedIn. We're not hard to find. We're open to engaging with you, and definitely stay tuned for future webinars as we continue to share from our 15 years of experience and expertise as we go along. So thank you so much to my fellow panelists for sharing your expertise today, and thank you all for joining. Take care, everyone.